So Yoann Valeri completed a master's degree at Sorbonne University in 2020 on the topic of cryptography, HPC, and floating point arithmetic. Since 2021, he's been working at CEA as a storage software developer, mostly focusing on open source tools for HPC such as Lustre, RobinHood, NFS Ganesha, and Phobos, while also participating in the IOC European project.
So thank you for the introduction, and I will present to you the RobinHood v4 progress report today. First, a reminder of what is RobinHood, even though I think everybody knows it by now. It aims to provide efficient and easy-to-use means to replicate and query any file system's metadata. We expanded a bit on that definition to also include object stores, but I will present that later in this presentation. Another reminder of last year's news. At the time, we had three tools in development, which were RBH Lustre Find to query and filter data in a backend based on Lustre-specific attributes. RBH FS Events to update said database with events, for instance, from Lustre. At the time, we had only the create time events and close events done. And the third one being RBH Find, mainly the new features like the size or extend attributes, and also actions for listing or sorting and dumping to files. So what's new since last year? Mainly four things. The first one being that RBH Lustre Find is near completion, in that the general tool and usage is done. It works very similarly to RBH Find, which means it supports all of its filters plus additional ones for Lustre. So, for instance, the OST used and things like that. I said the OST used, but also the FID and HSM stand currently. More will be added shortly. And it is used currently by invoking RBH LFind, which is just a shortened version of RBH Lustre Find. I've provided here a small example of of the usage of RBH LFind. I'm not going to go into all the details because it's very similar to RBH Find. We can see on the left we have a test directory called testdir with 3 files. I have listed here their names, their FIDs, HSM states, and OST used. And then we can use the very common find and sync semantics to synchronize this directory to a Mongo database using the Mongo database test, using then RBH LFind to query the data according to specific filters. So, for instance, you want all the files that have the HSM state archived, which is the first one, that are on OST1, the second one, that have this FID, and also since it uses the RBH Find syntax and find syntax in general, you can combine different filters. So, for instance, you can get all the files that have the HSM state none or that are on the OST0. You can get all the files that are on OST2 and that have the HSM state release, and also do a bit more complex filters, combining OR and AND filters with parentheses. The second part of what's new since last year, RBH FS Events is also near completion. The Lustre changelog reader and enricher is done. All events currently outputted by the Lustre changelog reader are managed, and the update to the database is also done. The last big work, which is ongoing, is the deduplication part. It is almost finished. There's only a few patches left to be done, but it's almost there. I've also included the command to invoke RBH FS Events. We use the command itself is separated into 3 parts, which are called changelog reading, for instance, using the Lustre source, which is the -- Lustre and the source specified here. The enrichment part, which is done using URI to specify how to retrieve extra information about the entries we managed to find in the changelog reader in the source. and the destination part, which can be either URI, for instance, to upgrade a Mongo database, which is the main usage, or to output this all the data retrieved either from the source or the enrichment part to the standard output using the dash. Currently the source to specify the Lustre changelog reader, Lustre changelog source, you have to specify the -- Lustre option, but we will most likely soon change it to a URI to also simplify the usage and align it with the enrichment part and the other tools. Here's an example of this command. So you can see on the top left the different commands we do to generate changelogs. So you first create a file called test archive. We then archive it using LFS HSM archive. Set an external attribute called user.test to the value 42. And then create another file called testpfl, migrate it to this layout. And you can see on the bottom all the changelogs that have been generated for these commands. You can see the create clause for the first file, the different HSM operations, the glider operation, and the other ones for the test.pfl file. We can then use the abhfs events command to get all the data in the changelog that I just presented, which were located on the Lustre MDT 000, using the -- Lustre option and the source. We then can enrich all this data to, for instance, retrieve the size of the file we just created, the OST used, and things like that, using the -- enrich and the array of the mount point of the Lustre mount point. And then synchronize all this data to a Mongo database called test. And so here the output of the database in question. So we just retrieve, the first line is a bit complicated, but we just retrieve the entry corresponding to the test archive file. You can see I've highlighted in red the important information. You can see the correct name, the path of the file from the Lustre mount point. And you can see also the HSM archive ID, which is currently 1, the HSM state, which is 9, but corresponds to the HSM state archived, and the extended attribute we set using user test. And currently the external attribute is just a binary data, but you can also query it, and it's planned in the future to have a much nicer way to retrieve, collect this data. But currently it's only a binary data. And we can see then the same information for the test.pfl file, the correct name, the correct path, and all the imported information regarding the file, and its layout on different OSTs. So you have the begin for the 2 components of the file, component flags, the end, the OST used. So you can see the file is on currently the OST 2, 3, and the -1 just to signify that there's a part of the file that isn't on an OST yet. You have the pattern, the pools used, the string count, and general information about the files. Next, on what's new since last year, we have developed a new backend specific to the European project IOC, which is based on a component developing it, which is the STR object store. So it's what I talked about at the start of the presentation. This STR object store is specific to IOC, but it's an object store that will be able to interact between different backends to store data in these different backends. So for instance, we have a simple POSIX backend, a motor backend for those who know about it. For both one is also present in the project. This development includes a new backend from RobinHood, which is the STR backend, and a new querying tool for IOC for this part, which is the ABH IOC find, which is also shortened to ABH iFind, like the Lustre one. Also, we are starting the work on the event updater, which will be done in a similar way with a backend specific to the STR object store and an enrichment part specific to it. And finally, the last part is a new retention feature to set an expiration date on different files using an external attribute. Currently, this feature supports three methods, which is to set an absolute expiration date, to simply set the date and say that the file will be expired on this date, so we can then archive it or just delete it. Relative expiration date, which is based on the maximum between the access and modified time of the file. So if you want to say this file is expired 30 days after its last access or modification, this is done using this. And an infinite retention date, which is more of a placeholder value to say to simply state that the file will not be expired, but in the future it may be so if another decision is made at a later point. This feature is currently tied to the Lustre backend, but it will be changed in the future, mostly using what I talked about earlier, which is the most likely a configuration file to say this attribute can be used outside of the Lustre part, and which can also be used for the POSIX backend or maybe for the STEP backend, for instance. And this feature in this data can be queried using two filters for ABH find. The expired filter, which is used to retrieve all the files that are currently expired at the moment of invocation of the command, and the expired at filter to retrieve so we can give a date to the command and retrieve all the files that are expired at the date in question. This specific filter can also support the retrieval of expired files before and after the date to retrieve all the files that expired after 30 days and things like that. Here is a small example of this feature. We have a test directory with 3 files in it, which reads simply the current date of the script, set the external attribute in question on the first file to the current time minus 30 seconds. For the second file, we set the infinite retention date. And for the third file, we set it to the last file's usage plus 30 seconds. We can then synchronize the data in question using the Lustre backend to a Mongo database. And then we can start using the different filters. So for instance, when we want to retrieve all the filters that are currently expired, at this point in time, there's only the first file, which is because it expired 30 seconds ago. If you want to retrieve all the files that expire at an infinite time, this is done by using the expired at filter with the inf value, and it only outputs the second file. We can retrieve all the files that expire before 1 hour into the future. So this is file A and file C, because file A expired 30 seconds ago, while file C expires in 30 seconds since its last usage. Retrieve all the files that will expire after 10 seconds, which is only file C. And finally, a simple modification, we sleep for 2 minutes and retrieve all the files that are expired at this point in time, which is file A, which is expired before the sleep, and now file C, because it was last used 90 seconds ago. Here are some early benchmarks. This is only done for the synchronization part of the RobinHood 4 and RobinHood 3. We've synchronized 2 million inodes on the CentOS Linux release 8.4 using a Lustre to 12.9. The version of RobinHood 3 is RobinHood Lustre 3.17. And the same material is used for this. So, I've put different benchmarks for depending on the usage of the two tools. We have the first line, the RobinHood 3 usage in the case of a single process, and the default usage for systems which were 16 threads for entry process and 2 for file system scan. So we had a time usage of 24 minutes and the database usage of 1.58 gigabytes. On a more optimized and fully optimized version, which is also parallelized on the largest directory detected in the database, it went down to 6 minutes at the same database size. and for RobinHood v4, using the very simple one, which is monoprocess and monothread. It was 1 hour to synchronize all this information. The database only weighs 0.4 gigabytes. And for a more optimized version, which is parallelized on the largest directory, but still monothread, because RBH Sync is inherently monothread. It's meant to be used parallelly by using multiple process. We went on to 27 minutes, still the same database length. Sorry. And so, what's next for RobinHood v4? We plan to finish the deprecation work, soon to be done. We also have the acknowledgement of events in RBHFS events. So, for instance, to say that the different events detected for the change log reader are acknowledged and remove them for the MDT. We also have pre-production tests of the tool planned during this year and the next year to retrieve more information and have better things to show for the next year. The ABH report tool to retrieve general information about the file system, so its usage, the size of all the files that are archived, and such things. And also improvements for this. For this tool specifically, the main one we plan on is to use the MPI file utils to improve the synchronization and improve the performance of it. But also other improvements. For instance, we haven't touched yet on the database modification. We haven't done any tuning to the Mongo database yet, but this is in the plan. And also better usage generally of the different cluster API and things like that. And finally, more filters generally for RobinHood find and RobinHood lost or find to complete them. It's an open source project, so if you want to help with development, the different projects have been moved on GitHub. It's before it was one project tool per tool, and it went to one project for the whole suite. The address is this one, and the reviews are still done on GitHub. So, for instance, we have some patches in review. The first one is this one, which is the first patch of the duplication stack, mainly the design part of the process. And the other patch I released today is a bug fix for the RBH Sync branching function. But also, if you want to install the suite and test it for yourself, you can, of course. And if you have any feedback or any things that should be improved, any user feedback, it would be appreciated. So thank you for the attention. If you have any question, I'd be happy to answer.
So, questions?
Could you say something a little about the equipment that you use to run the benchmarks?
I think I'll let Gael answer this one mostly. He's the specialist.
So I'm thinking about things like number of MDSs, that sort of stuff.
Okay, about the file system, it was a small Scratch file system, about 2 MDS. Okay, and the RBH server was one server, a pretty old one. I think it was with 2 as well processor, pretty old one. Okay, and which is very important is the backend disk, which is spin-wise. So it was not the real target for RBH databases. Okay.
Hi. Is this... Yeah, okay. You did benchmarks for sync, which is probably the worst case scenario. How does this search look on...
Yeah, sorry, can you repeat the question?
So you've done some benchmarks on sync, which is single-threaded, probably the worst case scenario. How does search compare between 3 and 4?
The find we had, we did some benchmark on it, but we have some issues regarding the validation of data. So I've decided not to include them in this presentation. I have some of them, but they were not conclusive yet to show.
Thanks.
Can you explain maybe where the difference in performance between RBH v3 and v4 on the sync is coming from?
First, the main thing you also have to consider is that in RBH v4, we retrieve more information than in RBH v3. So inherently, the time will be larger. But also, we haven't done yet any optimization of the time used. We mainly focused on the functionality parts to have something that is equal in functionality to RobinHood v3. But there's a large part of the development that will be done on optimization, and it will be done in the future. We have a bit of time before catching up to the time of RobinHood v3, but we have many hints about how to do it, and we just have to start working on them. Since most likely after the RBH FS events completion and the RBH tool, we will most likely focus on those aspects and improve this.
You said the expire feature is currently only available with a Lustre storage backend. What else can we expect in addition in future?
We would move this feature for general usage, so it will be also usable in the POSIX feature, in the POSIX backend, STR and all the other backends we plan to use in the future. This will be used most likely with a configuration file that we want with it to specify different extended attributes and how to use them in the database. So, for instance, consider this attribute as a date, as an int, and add easier access to this feature in general.
Other questions? Points of discussion?
Maybe one last one. RobinHood v3 is still under active development. Is there any plan to migrate to v4 at some point? Like, what's the roadmap for switching to v4 in production?
In production, we have some plans to use it, yes. I don't know the exact roadmap on it. RobinHood v3 is still in development, yeah, but it's a bit of a separate parts. We are mostly on the software development team working on the RobinHood v4. It would be more maybe the admins like Gael or William, which are working on RobinHood v3 still.
In not RBH v3, but v4, we use in production on specific cases when we need some XTTR tweaks about data lifecycle and so on. But for the all feature we have in RBH v4, we plan between 1 and 2 years to have RBH v4 in production.
Thanks.
So thanks, Yoann, for answers to the questions and your presentation.